Hello students, today in this part of differential equation I am going to take elementary types of differential equation. So basically there are three types of elementary types of differential equation. Number first, differential equation of variable separable type. Number second, that is differential equation of homogeneous type. And number third, that is differential equation of linear differential equation type. So in this chapter we will discuss about these three methods, that is differential equation of variable separable type, differential equation of homogeneous type, and the third one, that is the differential equation of linear equation type. Now let's do differential equation of variable separable type. So what is differential equation of variable separable? First one, that is I am going to take this differential equation of variable separable type. A differential equation of the form of dy by dx is equal to f of x comma y, where f of x comma y can be expressed as product of two functions, say f of x and g of x, where f of g of y, f of x and g of y, where f of x is the function of x and g of y is the function of y. So in other words, we can say any differential equation that can be written in the form of dy by dx is equal to f of x comma y, where f of x comma y can be expressed as the product of two functions, say f of x and g of x. Thus we can say this is the differential equation of variable separable type. Here dy by dx is equal to f of x comma y, which implies dy by dx is equal to f of x into g of y, because f of x comma y is the product of two functions, that is f of x and g of y. Now dy by dx is equal to f of x into g of y. If we separate variable here, means we will do y variable is in one side and x variable is in other side, which gives us dy divided by g of y is equal to dx f of x dx. Here we separate the variables, dy by g of y is equal to f of x dx. So integrating both sides here, that is integral of 1 upon g of y dy is equal to integral of f of x dx, which gives us, say, integral of 1 upon g of y is capital G of y, and integral of f of x dx, say this is capital f of x plus c. So thus g of y is equal to f of x plus c will be the solution of the differential equation. Since this solution here, that is this, contains an arbitrary constant c, thus we can say this will be the general solution of this differential equation. Let's do some examples related to the same topic. Let's take the first example. Solve the differential equation dy by dx is equal to 1 plus y square divided by 1 plus x square. So if we see here, this differential equation is of the form of dy by dx is equal to f of x comma y. So by separating variables here, by separating variables here, we get dy divided by 1 plus y square is equal to dx divided by 1 plus x square. As we have to find the value of y, thus we have to integrate both sides with respect to x. So integrating both sides, we have integral of dy divided by 1 plus y square is equal to integral of dx divided by 1 plus x square. As we know that from integral calculus, integral of dy divided by 1 plus y square is tan inverse of y, because we know that integral of dx divided by 1 plus x square is tan inverse of x, and integral of dx divided by 1 plus y square is tan inverse of y. So which is equal to integral of dx divided by 1 plus x square is tan inverse of x plus c, but it is better to take c as tan inverse of c, because the whole function here is in terms of tan inverse. Thus it is better to take an arbitrary constant tan inverse of c. Here tan inverse of y is equal to tan inverse of x plus tan inverse of c, which implies tan inverse of y is equal to, as we know that from inverse trigonometric functions, tan inverse of x plus tan inverse of c is equal to tan inverse of x plus c divided by 1 minus xc, because we know that from ITF, that is inverse trigonometric functions, formula is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. So here we apply this formula, thus which implies y is equal to x plus c divided by 1 minus xc will be the required solution of the given differential equation. So here this solution contains an arbitrary constant c, thus we can say this is the general solution for this differential equation. Let's do another example related to the same concept. That is example number 2. dy by dx plus y into y minus 1 divided by x into x minus 1 is equal to 0. Let's solve the given differential equation. Again, here we separate the variables. dy by dx is equal to minus times y into y minus 1 divided by x into x minus 1. So by separating variables here, dy divided by y into y minus 1 is equal to dx, or minus times dx divided by x into x minus 1. So dy divided by y into y minus 1 is equal to minus dx divided by x into x minus 1. So integrating both sides here. Now to solve the integral of both sides, integral of, here this can be written as 1 divided by y minus 1 minus 1 divided by y dy, because if we solve this we will get this, which is equal to minus times integral of 1 divided by x minus 1 divided by 1 by x dx. So integral of 1 divided by y minus y dy minus integral of 1 upon y dy is equal to minus integral of dx divided by x minus 1 plus integral of 1 by x dx. So integration of 1 upon y minus 1 is, so integral of 1 divided by y minus 1 dy is log of modulus of y minus 1 minus integral of log of mod of y is equal to minus times log of mod of x minus 1 plus, as we know that integral of 1 by x is log of mod of x plus integral constant, say log of c, because the whole function contains log, thus it is better to take integral constant log c. So as we know that log m minus log n is log m by n, therefore this is log of y minus 1 divided by y. This is log of log m minus log n, this will be log x divided by x minus 1 plus log c. So which is equal to log of y minus 1 divided by y is equal to log m plus log n, that is log mn. So this is equal to log of xc divided by x minus 1. So taking anti-log both sides, we get here y minus 1 divided by y is equal to xc divided by x minus 1. So which implies x minus 1 into y minus 1 is equal to xyc will be the general solution for this differential equation. Let's do example number 3 for the same concept. E raised to power x minus y dx plus e raised to power y minus x dy is equal to 0. So we have to solve this differential equation. So given is e raised to power x minus y dx plus e raised to power y minus x dy is equal to 0. Write this In other way, that is e raised to power x divided by e raised to power y dx plus e raised to power y divided by e raised to power x dy is equal to 0, because a raised to power m minus n can be written as a raised to power m divided by a raised to power n. So as we know that a raised to power m minus n is equal to a raised to power m divided by a raised to power n, so we apply this formula here, so which implies if we cross multiply here, this is e raised to power x square, that is e raised to power x whole square, which is same as e raised to power 2x, because a raised to power m whole raised to power n is equal to a raised to power mn. So this is 2x dx plus e raised to power 2y dy divided by this whole term, e raised to power y, e raised to power x divided by e raised to power x plus y, because e raised to power y into e raised to power x is equal to e raised to power x plus y is equal to 0, which implies, so solving here, e raised to power 2x dx plus e raised to power 2y dy is equal to 0, because this is, as we know that e raised to power x is always greater than 0, in other words we can say that e raised to power x plus y is a positive number, that is greater than 0. Here we can multiply here, so this term will become 0, or we can say e raised to power 2x dx is equal to minus times e raised to power 2y dy. So integrating both sides, e raised to power 2x dx is equal to minus times e raised to power 2y dy. As we know that integral of e raised to power ax dx is equal to e raised to power ax upon a. So e raised to power 2x, the integral of e raised to power 2x dx is equal to e raised to power 2x by 2 is equal to minus times e raised to power 2y by 2 plus c. So this is equal to e raised to power 2x plus e raised to power 2y minus 2c is equal to 0 will be the solution for this required differential equation. Now let's take the another type of differential equation, that is differential equation of homogeneous type. Second one is differential equation of homogeneous type. So let's first do what are homogeneous functions. First we will take what are homogeneous functions, or in other words, what is a homogeneous function? A function f of x comma y is said to be homogeneous function. Homogeneous function if we substitute x by lambda x and y as lambda y will satisfy the equality or hold is the equality f of lambda x comma lambda y is equal to lambda power n of f of x comma y. So any function that will satisfy this equality by substituting x is equal to lambda x and y is equal to lambda y, where lambda is any scalar or real number, thus function can be, or this function can be known as homogeneous function. For example, if we have function say f of x comma y is equal to x square plus y square. So substituting x by lambda x and y by lambda y, we have f of lambda x lambda y is equal to, here this is lambda x square plus lambda y square, which is equal to lambda square times x square plus y square, which is equal to lambda square times f of x comma y, because x square plus y square is equal to f of x comma y. Thus we can say this function is a homogeneous function, more particularly of degree 2, because here n is the degree of the homogeneous function. Here n is degree, and this n may be any real number. This n may be any real number. Thus we can say f of x comma y is equal to x square plus y square is a homogeneous function of degree 2. Now let's take another example. Say f of x comma y is equal to sin x plus sin x plus cos y. So if we substitute here x by lambda x and y as a lambda y, we get sin of lambda x plus cos of lambda y, which is not equal to lambda times f of x comma y, because here lambda cannot be eliminated from the angle of sin and cos. Thus we can say f of x comma y is equal to sin x plus cos x is non-homogeneous function. Now if we have an example third, like f of x comma y is equal to sin of y by x plus cos of y by x. So here you can try here, if we substitute here x by lambda x, y as a lambda y, we get here sin of lambda y by lambda x plus cos of lambda y by lambda x, which is lambda time, or which is you will get here lambda power 0 f of x comma y, because if we put here lambda y and lambda x, lambda will be cancelled, and lambda here lambda will be cancelled. So this is same as sin y by x plus cos of y by x. So thus we can say this is the homogeneous function of degree 0. Now our topic is differential equation of homogeneous function. So we clear the concept what are the homogeneous functions. Let's take or do what are homogeneous differential equations. Now let's take homogeneous differential equation of first order and first degree. Homogeneous differential equation of first order and first degree. A differential equation of the form of dy by dx is equal to f of x comma y divided by g of x comma y. where f of x comma y and g of x comma y are homogeneous functions of same degree. Say n. Then this differential equation is known as differential equation of homogeneous type. That is homogeneous, any differential equation or a differential equation of the form of dy by dx is equal to f of x comma y divided by g of x comma y, where f of x comma y and g of x comma y are homogeneous functions of the same degree, say n. Thus we can say this differential equation is of homogeneous type. So f of x comma y and g of x comma y are homogeneous functions of the same degree. Thus f of x comma y can be written as x raised to power n of f of y by x, and g of x comma y can be written as x raised to power 1 of x raised to power n g of y by x. So substituting here, put y is equal to vx. So the dy by dx is equal to as we f of x comma y is equal to x raised to power n of f of y by x divided by x raised to power n of g of, say this is f1 of y by x and this is g1 of y by x. So taking these substituting values here, we get, so if we differentiate here with respect to x, we will get the value of dy by dx. So differentiate here with respect to x, we get dy by dx is equal to, so v and x using product rule of differentiation, we get here v as it differentiation of x is 1 plus x as it differentiation of v is dv by dx. This value and this value, put these values in there, we get v plus x times dv by dx is equal to, here x raised to power and x raised to power will be cancelled. This will be f1 of y by x. Here y is equal to vx, which implies y by x is equal to v. So this will be f1 of v divided by g1 of v. So here v plus x times dv by dx is equal to f1 of v divided by g1 of v. So separating variables here, we will get x times dv by dx is equal to f1 of v divided by g1 of v minus v, transposing v here, which is equal to f1 of v minus v times g1 of v divided by g1 of v. So after separating variables here, we get dx by x is equal to g1 of v divided by f1 of v minus v times g1 of v dv. So integrating both sides here, we have integral of dx by x is equal to integral of g1 of v divided by f1 of v minus v times g1 of v dv. So after integrating this, we will substitute, after integrating replace value of v to get the solution of differential equation. So this is the procedure how to find the solution of differential equation of homogeneous type. Let's do some examples related to the same concept. Let's take the first example. Solve the differential equation dy by dx is equal to x square plus y square divided by 2x square. So first of all, we will check this, is this function homogeneous or not. So as we know that this whole function is equal to f of x comma y. So after replacing x by lambda x and y as a lambda y, we have f of lambda times x lambda times y is equal to lambda square x square plus lambda square y square divided by 2 times lambda square x square. So taking lambda square as a common, we will get lambda power 0 x square plus y square divided by 2x square, which is equal to lambda power 0 f of x comma y. So thus this function is a homogeneous function of degree 0. Now how to solve this differential equation? As we already discussed in the definition, what is the procedure to how to solve the differential equation of homogeneous type? Rewrite here dy by dx as taking x square, or in other words we can say dividing numerator and denominator throughout by x square, we will get 1 plus y by x whole square divided by 2. So keep this is first. So second step is put y is equal to vx and get the value of y by x and dy by dx, which implies y by x is equal to v, and after differentiating here we get dy by dx is equal to v as the differentiation of x is 1 plus x as the differentiation of v is dv by dx. Here we are differentiating with respect to x. So substituting these values in equation first, we get v plus x dv by dx is equal to 1 plus v square divided by 2. So separating variables here, we have x times dv by dx is equal to 1 plus v square minus v divided by 2, so which is equal to x times dv by dx is equal to, this is 2v, this can be written as v square minus 2v plus 1 divided by 2, or we can say here dx by x is equal to 2 divided by v square minus 2v plus 1, this is same as v minus 1 whole square dv. So here this is x dx by x. So integrating both sides here, so integral of dx by x is equal to 2 times integral of dv divided by v minus 1 whole square, As we know that integral of dx by x is log of mod of x is equal to 2 times. What is integral of dv divided by 1 minus v square? As we know that differentiation of 1 by x is minus 1 by x square. That is, that integral of dv divided by v minus 1 whole square is minus times 1 upon v minus 1. So log of x will be minus 2 divided by v minus 1. So replacing the value of v here, or we can say here v minus 1 times log of mod of x is equal to minus 2, replace v by y by x. So this will be y by x, that is y minus x by x into log x is equal to minus 2. Final result will be y minus x log of x is equal to minus 2x plus, say integral constant here is c plus c. So solve here. This will be minus 2 plus c times v minus 1. Minus 2 plus c times v minus 1. So for this step, rewrite the whole. This is v minus 1 log of x into 2 times, this is, sorry, this is int. This is 2 minus 2. So this will be, we replace y, v as a y by x, we get y minus x by x into log x is equal to minus 2. Plus here is c, this will be plus c times v minus 1 plus c times y minus x by x will be the solution of the differential equation. Let's take the example number 2 of the differential equation of homogeneous type. So example number 2 is dy by dx is equal to y by x plus tan y by x. Here you can check here, this is the homogeneous function of degree 0. Now here we have to solve this homogeneous differential equation. So by substituting here or put here y is equal to vx implies here v will be y by x and dy by dx is equal to, so differentiating here v plus x times dv by dx. Substituting these values in equation first, we have v plus x times dv by dx is equal to v plus tan v. So separating variables here, x times dv by dx is equal to, so v cancelled, is equal to tan v. So dx by x is equal to dv divided by 1 upon, that is 1 by tan v. So which is same as cot v, because 1 upon tan v is cot v dv. So integrating both sides, integral of dx by x is equal to integral of cot v dv. So as we know that integral of dx by x is log of modulus of x, and integral of cot v is log of sin x, because cot v can be written as cos v divided by sin v. Sin v. As we know that here numerator is the exact differential coefficient of denominator, so integral of this will be log of sin v, because we know that integral of f dash of x divided by f of x dx is log of modulus of f dash of x. So which is equal to log of sin v plus log c, because the function contains log, so it is better to take integral constant in terms of log, that is log c. So log x is equal to log of c times sin v. Why? Because we know that log sin v plus log c is log mn. This is log m, this is log n, and log m plus log n is log mn. So replacing here the value of v, we get log of x is equal to log of c times sin of y by x. So taking anti-log both sides, we get x is equal to c times sin of y by x will be the solution for this differential equation. Now let's take the differential equation of third type, that is linear differential equation. Now let's take the differential equation of third type, that is linear differential equation. Linear differential equation type. A differential equation of the form of dy by dx plus py is equal to q. Any differential equation that can be written in the form of this, or in other words, we can say a differential equation that are of the form of this dy by dx plus py is equal to q, where p and q are functions of x only. Such differential equations can be known as differential equation of linear differential equation type. Now, what is the procedure or how to solve such type of differential equations? Let's write the definition here, as we have dy by dx plus py is equal to q. Take, this is first multiplying here both sides, multiplying both sides e raised to power integral of p dx, we get here e raised to power integral of p dx into dy by dx plus py is equal to e raised to power integral of p dx into q. So multiplying here term by term, we get e raised to power integral of p dx dy by dx plus e raised to power integral of p dx into py is equal to e raised to power integral of p dx into q. After seeing this here, this is equal to d by dx of e raised to power integral of p dx into y is equal to e raised to power integral of p dx into q. If we differentiate these two functions with respect to x, we will get this. So taking e raised to power p dx as it, differentiation of y will be dy by dx, plus taking y as it, differentiation of e raised to power p dx. As we know that differentiation of e raised to power x is same e raised to power x. So write here e raised to power integral of p dx, and internal differentiation of e raised to power p dx will be p. So this encircled step is equal to dy by dx into e raised to power p dx into y is equal to e raised to power integral of p dx into q. So we had to eliminate here dy by dx. So we will integrate both sides, as we know that integration and differentiation are reverse process. So to eliminate dy by dx here, we will integrate both sides. So integrating both sides here, integral of d by dx into e raised to power integral of p dx into y dx is equal to integral of e raised to power p dx into q dx. So this will be cancelled, which because these are reverse process each other, these are reverse inverse each other, which is equal to e raised to power integral of p dx into y is equal to integral of e raised to power integral of p dx into q dx plus c. So this will be the solution of the differential equation that are of the form of dy by dx plus py is equal to q. In this first step here, we multiply both sides by e raised to power p dx. This is known as integrating factor. Here we multiply this by first equation, that is dy by dx plus py is equal to q. So this step or this is known as here e raised to power integral of p dx is known as integrating factor. Integrating factor, and is denoted by I dot f. Here I dot f means integrating factor. Let us do some examples related to the concept of linear differential equation type. Solve the differential equation dy by dx plus 3x is equal to e raised to power minus x. So here if we equate this differential equation to the definition of linear differential equation, so we know that differential equation, that is linear differential equation, is of the form of, so if we equate these two equations here, we get here p is equal to, here this is y, 3, and q is equal to e raised to power minus x. As we already discussed, the solution of differential equation is y into integrating factor is equal to integral of integrating factor into q dx plus c. So this is the solution of linear differential equation. First of all, we will calculate integrating factor. So as we know that integrating factor is equal to e raised to power integral of p dx. So here if is equal to e raised power integral of 3 dx, which is equal to e raised power 3 times integral of dx, which is equal to e raised power 3 times, what is integral of dx? Integral of dx is x. So this is the integrating factor here. So solution will be, as we know that solution of linear differential equation is y into integrating factor is equal to integral of integrating factor into q dx plus c. So which implies y, what is the integrating factor here? E raised power 3x. Integral of e raised power 3x into q, what is the q? That is e raised power minus x dx plus c. So which is equal to y into e raised power 3x. So here, as we know that a raised power m into a raised power n is equal to a raised power m plus n, here we get e raised power 2x dx plus c. So this is equal to y into e raised power 3x is equal to, what is the integration of 2x? Yes, e raised to power 2x by 2, because we know that integration of e raised to power ax dx is equal to e raised to power ax by a plus c. So which implies y is equal to, so dividing throughout by e raised to power 3x, we will get e raised to power minus x by 2 plus c times e raised to power minus 3x will be the solution of this differential equation. Let's do another example related to the same concept. Let's take the example number 2nd. So here example number 2nd is dy by dx plus y by x is equal to x square. So equating this differential equation with the definition of linear differential equation, that is dy by dx plus py is equal to q. Here we get p is equal to 1 upon x, q is equal to x square. What will be the integrating factor? Integrating factor will be the e raised power integral of p dx. That is e raised to power integral of 1 upon x dx. That is e raised to power integral of 1 upon x is log of x, which is same as x, because e raised to power log x is equal to x. So this is the integrating factor. As we know that solution of linear differential equation is of the form of y into integrating factor is equal to integral of integrating factor into q dx plus c. Therefore solution will be y into x is equal to integral of x into x square dx plus c, which is equal to integral of x cube dx plus c, which is equal to, what is the integration of x cube? X raised to power 4 by 4 plus c. Therefore y of x is equal to, or y into x is equal to this. Dividing throughout by x, we get y is equal to x cube by 4 plus c times x raised to power minus 1 will be the solution of this differential equation.